All right. Okay, cool. So let's start from where we left off yesterday. Today we are going to be looking at how to detect malware with Wazoo. And from yesterday, if I remember correctly, I had walked through the whole feature set of Wazoo by visiting each menu out here and showing you a general outline of what Wazoo can provide you with. And yesterday we had downloaded and installed Wazoo, went through the dashboards, and then enrolled an agent, one specific agent to one specific node. Um, After we have enrolled this agent, we looked at all the different information which is being collected from that specific agent through the different dashboards which we have at the Wazoo level. So we are going to be looking today at how to catch malware using Wazoo. One of the most common functionalities of Wazoo is uh, to use it to monitor for changes on a specific system. As I mentioned yesterday, that feature is called file integrity monitoring, which monitors critical files on the system and raises an alert whenever it detects that a certain files which are critical to the system have been modified. Now, Wazoo comes in with a built-in list of files which it would monitor by default. Say any file under the bin folder and files under the boot folder which are critical for the system to boot up, and a lot more different files. Any file under user bin, or basically anything that is accessible across the whole system. So now Wazoo monitors all these files by default to make sure that these files, whenever they get modified, the users get notified. The SOC analyst can view events related to any of these files getting modified in the Wazoo dashboard. Now, what we will be doing is we will be taking Wazoo's file integrity monitoring and extending it to watch for changes on specific directories. In our example, we will be confining those to a very limited directory. We will create a sandbox folder, and inside that folder, we will be downloading malware. And we will be making the Wazoo agent monitor this specific folder. Of course, on a real production setup, you would be configuring Wazoo to watch almost every file, every folder on your target system, on your endpoint. Now, that is not feasible here since this is a PC which I use for personal use. I would rather Wazoo watch a specific folder. So now what I'm going to do is use something called Yara to detect malware. So, for those of you who are not aware of what Yara is a solution which was developed by VirusTotal. It is a standard framework to sort of recognize patterns present inside files. Now, this is basically just a collection of rules and a collection of strings inside each rule to match, and also conditions that match each string. So now this is one example of a Yara rule. Now these strings inside the Yara rule mention specific patterns to look for inside any given file, and if the condition is satisfied by matching either of these strings, for example, the Yara framework will throw you an alert saying that this specific rule has been triggered. Now, this can be used for malware detection, where similar to a signature-based antivirus, you would use specific strings to configure Yara to scan for malware, and then you would basically use Wazoo to integrate with Yara. Yara is a standalone tool which is totally separate from Wazoo itself. Now you can use Yara standalone, or you can use it as part of Wazoo, and so on and so forth. There are several different ways of using this. Now, Wazoo is having a good integration with Yara, and we will be seeing how to perform this integration. To recap, Yara basically looks for files and tries to match certain patterns inside the files. If it matches those patterns, it will raise an alert saying that this rule has triggered for this specific file. Now you can extend the framework by writing rules for each piece of malware, and those rules will be triggered whenever that specific malware is encountered. And yeah, let's go ahead and get started. The first thing you will need to do is download and install some dependencies onto your system. As I mentioned previously, this is a Kali Linux system, and this already has all the dependencies installed. If not, you can just go ahead and install all these dependencies as mentioned in the Vasu documentation. The next thing we will do is we will download the source code for Yara onto my local system over here. Now this is a tar.gz archive. So I'm going to just extract this archive onto a local folder here. And once I have extracted, I can change into that specific folder. Now this is a framework which you will have to compile by source. I believe there might not be any pre-compiled versions available, and even if they are, then I guess they are only available for Windows. So for Linux, you might need to download and compile Yara from source, which is what we are doing right here. And the latest version of Yara seems to be 4.5.1, but we are checking out 4.2.3, which is a little bit of a concern because there might be extra features released in the later versions. But let's not get into all of that at the moment. Let us just start compiling. After we have downloaded the code for Yara, the first thing to do is /bootstrap.sh. Execute that specific shell script file which is provided by Yara to sort of bootstrap the compilation. Now, after bootstrap.sh, you will be having a configure script which is created under the root folder. Now we need to execute this. Again, this is all pretty standard methods of compilation for almost any piece of software which is distributed as source code. For several pieces of Linux software, it's typical to just do /configure make and then make install. That's how you would typically compile any piece of software from source. And yeah, we are following a similar process here. After we do /configure, the next thing to do will be to start compiling using make. Now, after I have done make, it would have finished compilation, and all the files which are needed, the output is generated, and it's basically stored here. You can see two new files being created, Yara and Yara C. So now this means that Yara has been compiled successfully. Now to install it, you just need to do sudo make install, and this will install Yara onto your system. Now, one more thing is whenever any piece of software you have has a shared library, something like libyara.so or so on, what you need to do usually is after you have installed it, it is recommended to do sudo ld-config so that all the shared libraries are refreshed on your system, and your tool will be ready to use. Let us just execute Yara and see if that has been installed properly. So I execute Yara and it throws me an error saying wrong number of arguments, which is totally fine. I was just wanting to see if the Yara tool is executed properly. So now we have compiled and installed Yara from source. And the next step will be to download some rules for this Yara tool. So what we are going to do is we are going to copy this entire snippet which is provided in the documentation. It's going to create a folder called Yara rules, and it'll download a specific Yara rules file onto /tmp/yara/rules. So let me just copy this whole thing and paste it here. Oh, sorry. And paste it here, and it's going to download all the Yara rules onto slash tmp slash Yara slash rules. Now, once this has been completed, we can see that the Yara rules are present over here. The next step to do will be to configure the Wazoo agent to integrate with Yara. For this, we are providing a helper shell script, which will take input from Yara and which will pass the input onto, sorry, which will take input from Wazoo and pass the response onto Yara. And once it executes Yara and looks at the output, it will be able to determine whether that piece of file is a malware or not. So we will be uh, copying this whole shell script and pasting it into var ossec. So I will need to be root to do this. So I'm going to go to var ossec etc and sorry, var ossec active response bin. This is the folder I need to be in, and here I will need to add the yara.sh shell script. So I just copy it over verbatim and just put yara.sh here and paste and close this file. So now the shell script is ready. This Yara integration should next be exposed to Wazoo. Now the Wazoo agent needs to know how to execute this Yara integration. Before we move on, we will need to set the proper ownership and permission for this shell script. So we will just go ahead and do that. We will be setting the owner user to root, the owner group to Wazoo, and we will be setting the permissions to 750, which means the owner can do anything and the group can read and execute this file. Now, moving on, the next thing we need to do is we need to tell Wazoo which folder to monitor for file changes in. This is the part where we start the Wazoo agent to monitor specific folders. Now, typically, when you want to monitor for folders and files, you would want to monitor a user's home folder or their downloads folder and so on and so forth to make sure that they're not downloading any piece of malware onto their system. Um, Here in this specific example, I'm going to be monitoring a controlled folder, a malware folder under the temp folder. So let me just go to the Wazoo agent configuration and add this bit of code there. Now this is there under var ossec etc. There will be a file called ossec.conf where I will need to add this specific configuration. Now this should be added inside the syscheck block, it says. So I'm going to go ahead and add, here we have the syscheck block right here. We have the syscheck block here and we will be adding this specific folder inside the syscheck block. Now I will close this file and the next thing to do is restart Wazoo agent. So just service Wazoo agent restart. We'll restart the agent and it will start monitoring that specific folder. And now we will just wait for the agent to restart. Then we will go to the Wazoo dashboard and go to the file integrity monitoring tab. And if we search for slash tmp here, we will not see anything right now because the Yara folder has not been created yet. So we can go ahead and create that while we are at it. So slash tmp slash Yara slash malware. So once we have created that, we can see that it's a perfectly empty folder. We can try creating a test file over here and we can refresh the Wazoo dashboard to see if Wazoo is able to pick up on these changes. And it would seem that Wazoo has not really picked up on these changes yet, which would have been done by now typically. Now let us restart the Wazoo agent once again to just to make sure that we have everything right. After we have restarted the agent, it should now pick up on that folder and it should at least try to report any changes which are being carried on inside that folder. So let us just go back to file integrity monitoring, go to the inventory tab and search for files. And now we can see that inside inventory that it has successfully started monitoring the TMP Yara malware folder. Now the Wazoo agent will be able to pick up on any changes we make under this specific folder. And if you look at events, you might be able to see whenever a specific file gets modified. Now let's not worry about that and let's proceed with the rest of this. The next thing we need to do is we need to add a couple of rules to the Wazoo server. So now any changes we make going forward will not be to the agent, but rather these are going to be to the Wazoo server itself. So now what we are going to do is copy this little snippet over here and add it to local rules.xml on the Wazoo server. Now, since I have the Wazoo server on a Docker container, I'm gonna have to exec into the container to sort of access the server. Now, let me pop a shell inside the Wazoo server. Uh, Typically on a Wazoo Docker deployment, you will have three components, which is the Wazoo dashboard, the Wazoo manager, and the Wazoo indexer. Any and all changes related to the Wazoo server needs to be made on the Wazoo manager container. And this is the container I'm going to exec into. Now I have popped a shell onto the container. I'm going to be going onto localrules.xml, which is under var osec etc rules. And to localrules.xml, yeah, since this is a container, it might not really have the tools which I'm wanting. So I'm going to just install the VI editor onto this container before I'm able to edit any files over here. Now we just wait to install, and now we should be able to access the local rules.xml. All right, now we have opened this up on an editor. Now if you see, this would typically have one example rule already. You can get rid of this if you don't really want it, or you can keep it, and you can just copy this rule over and paste. I'm sorry, seem to have pasted it twice. Yeah. Okay. So we just ignore the initial rule which we have and we paste the rest of the rules beside it, or below it. And once we are done, we can close this. We also need to add something to local decoder.xml as specified here. So we're going to be heading over to the decoders folder and adding something to local decoder.xml, just a small copy paste. And once that is done, the next thing to change will be the main ossec.conf file on the Wazoo server. Now, there is a little bit of a confusion for SOC analysts who are specifically using Wazoo. There are two ossec.conf files. The one is on the agent itself, the one on the server. And typically, when you're following the documentation, it will be clearly mentioned which file you will need to make these changes to. So make sure that you're modifying the right files, or, So, yeah, you copy the snippet over and you will need to add this to ossec.conf on the Wazoo server. And now, yet another quirk with the Docker deployment for Wazoo is that this ossec.conf, the ossec.conf which is present here, actually comes from a mount point. Um, I will not be able to show it from within the container, but I can show it from the Wazoo Docker deployment. Since yesterday we had used a single node deployment. If you look at the docker compose.yaml file over here, you will be able to see that it mounts the ossec.conf file from the current folder under ./config slash Wazoo cluster slash Wazoo manager.conf. Now, this is the file which is present on the host system, not on the container. Now, this Wazoo manager.conf is a file which is present on the host system, and this file will be picked up and mounted as ossec.conf inside the container. So instead of making the change directly to this file on the Wazoo server, we will be making the change to this file and we will be using this. So let us just edit this file and add that specific snippet here. Now the ossec config tag at the top and bottom can be removed because this whole file starts with ossec config and ends with ossec config. Now we can just basically go ahead and put that right there in the middle and make sure that it's well placed. So yeah, we define a command in the first place. The name of the command can be anything which Wazoo recognizes. The name of the command here is used by Wazoo to sort of uniquely identify that command across all the different list of commands. And the executable name should be the name of a file inside the active response folder. If you remember, we created a yara.sh executable inside the active response slash bin folder. And the extra arguments which need to be passed to the yara.sh executable, and timeout allowed is just another option which needs to be added. So now we have added the extra contents to the Wazoo manager.conf, which is ossec.conf by proxy. And we need to restart Wazoo Manager to apply these changes. So we are going to do exactly that. Now, this is to restart Wazoo Manager when we are restarting it on a bare metal system. Since we have installed it inside Docker, we just need to use Docker restart and the container's name. We're just going to go ahead and do that to sort of restart the manager itself. And then we will be able to check if the rules have been loaded successfully. So let us head on over to rules and see if the Yara rules have been added. And we can see rule ID 100, 300, 100, 301 to sort of describe when files are modified or added onto the folder which we are monitoring. And then 100, 800 to group Yara rules together, and 100, 801 to match for any alerts thrown by Yara. Now the rules have been successfully loaded onto the Wazoo manager, and we can just go ahead and start downloading malware onto our system. So now what we can do is we can remove the test file over here, or we can just keep it as is. Not going to be much of a difference with that. The next thing to do is to use this specific shell script which the Wazoo documentation provides to download malware onto your system. So we're going to be creating a malware downloader shell script. We're going to paste the contents of the whole shell script right here onto the malware downloader folder, and we will close this, and it gives me an error. So yeah, let me just do this. Now we have written the shell script successfully. The next thing to do would be to just execute it using bash. Now, this shell script, what it does is basically it uses this function called fetch sample, which is just a proxy to curl. Now, curl, it hits certain URLs under the Wazoo demo S3 bucket, and it downloads certain files from that specific S3 bucket. Now, the Wazoo demo S3 bucket contains all these sample malware which you can download onto your system to check if the integration is working properly. And there's four different malwares over here. One is Mirai, one is Xbash, one is VPN filter, and one is a worse Linux PHP shell. So these are four different pieces of malware. Everything ranging from a web shell to a botnet ransomware and so on. So we will be downloading all of these, and just downloading them is more than enough for Wazoo to start catching them. Since we have file integrity monitoring enabled, uh, any and all files added to that specific folder will immediately start raising alerts saying that a file has been created on that specific folder. Now, you would also expect users to go and create files on their system in a typical workflow. Of course, they are users, they will start creating files, using files, and so on and so forth. Now, the first thing we are doing here is a chained approach. The first thing is we will uh, start throwing alerts for each file that gets created on a system. And the second stage of that alert is basically to utilize the previous alert which we have to sort of trigger the active response integration. Now, the Yara integration which we have is essentially an active response script. And as I told you earlier, it is used to respond to specific alerts. And that's what we are doing out here. We throw alerts whenever a file gets modified. And the second stage will be to sort of inherit from that alert and you know trigger an active response command to be executed. In this specific case, the command to be executed will be uh, a shell script which will trigger Yara using the locally downloaded Yara rules. Again, the shell script is right here, the shell script which we have already seen. This shell script will trigger Yara on the recently created files. And that would pretty much be the idea of how this works. Now, you can also start writing integrations like these on your own. Apart from whatever Wazoo provides, it's always, a good idea to start writing integrations like these on your own. And yeah, this is how we extend the functionality of Wazoo basically. All right, on to the actual demonstration. The next thing to do after creating the shell script is to just go ahead and execute it. I want to say yes to the malware downloading onto my system. And this might take a while because it's four different pieces of malware, might range from anything between KBs to like MBs in size, or maybe even gigabytes in size for each file. Let the downloads finish, and while the downloads are happening, if you check the Wazoo dashboard, you will still be able to see file integrity monitoring events which are happening on a specific host. Let us just head on to the inventory tab, which is taking a while to load right now. All right, we can skip inventory and just look at events maybe. And yeah, right there we can see that uh, these files have been modified. You can see a bunch of these files have been modified. Alerts which are coming in. This alert is for Xbash, and you also have those alerts for Mirai. And as we said earlier, we downloaded four or five different pieces of malware. So these alerts will keep on raising for each specific file which is downloaded onto the directory. Let us refresh this page. Let us head on over to events, and we can see all these different files. Now you have Mirai, you have Xbash, a bunch of alerts for Xbash. It seems to be a big file. And then you have VPN filter, and then you have web shell. All these different files being added is starting to raise an alert each time. And that's pretty much it. You will start getting in all these alerts, and the next step will be to check the active response integration to see if it is working properly. So now, the next thing to do will be to sort of test this out. Um, let's head on over to threat hunting and see if we have any alerts which are related to the compromise using the Yara rules. And immediately we can see, if we head on to the threat hunting tab and click on events, we can immediately see that we have somewhere around 311 hits, and it says this file is a positive match for this specific Yara rule. So xbash is the file name, and of course the Yara rule is also appropriately named malware underscore xbash underscore py. And yeah, after that we can, if we want to specifically filter down to this specific alerts, what we can do is we can expand on this alert here. We can scroll down to role.groups Yara. There will be a specific role.groups Yara, and you can basically just filter for that specific value. And immediately in the threat hunting tab in the under events, you will immediately start seeing only those hits which are related to Yara rules. Now if we go back to the previous thing, we can see that we have hits for things other than Yara rules. Say, for example, the file integrity monitoring events which we previously saw. This all just adds to the noise. This adds a lot of different rules and alerts to the noise. So, what we will be doing is to basically just take this Yara rules and filter for those, and here we will be able to see how many hits. Say, for example, here it's 154 hits. Now we will be able to look at all the 154 different hits which have been produced for this specific rule. And as you can see here, Mirai got detected as an ELF malware. Xbash got detected as Xbash, and you have the VPN filter, which is getting detected as another piece of malware, and a PHP shell. Now, again, it all entirely depends on which Yara rules you actually have. So, if you go to this Yara rules folder and check out this Yara rules file, you can actually take a look. And this is basically just a demo rule set. And this will only contain a few rules of Yara. If you want to be able to detect a lot more, you will definitely need to add to your rule set over here. Now, this is a demo rule set provided by some company called Valhalla, and you can basically just go and look for, you know, the same thing. While we are downloading it, you can actually see that we are downloading it from this specific, URL. We are downloading it from valhalla.nextronsystems.com, and this really does not contain a lot, compared to a traditional Yara rule set, but we still have a fairly sizable amount of rules over here. Of course, this is just for demonstration purposes, so this is not really something which is useful on production cases. There are definitely pre-built Yara rule sets which you can use for production, which a lot of different open source providers will typically just open source. You have in this specific rule set, you have potentially unwanted applications, CPU ID, and potentially unwanted vulnerable drivers. And the same thing, if you scroll down, you can see a lot of these detects vulnerable drivers. Now, this is also something which is uh, a beneficial way of using Yara rules. Now, Yara rules can't just be, don't necessarily just need to be used for detecting malware. You can also use it for detecting vulnerable versions of files, even if they are compiled files, even if they are files which are not really, present in the source code form. You can look for specific signatures inside the files. You can look for specific patterns inside the file to determine which version of file, say, for example, is being used. And that itself will lead to a really good identification of files which are vulnerable to specific vulnerabilities. Now, this is something which is an excellent use case for Yara. You can use it to, like, apart from detecting malware, you can also use it to sort of detect vulnerable versions of files. Of course, you will have to develop your own set of Yara rules if you have to detect vulnerabilities inside, like, your own applications. But again, I'm pretty sure that there will be a lot of open source providers who sort of distribute Yara rules to detect vulnerabilities. And let us just keep scrolling. This is a bunch of exe files which are vulnerable to something, and so on and so forth. Again, a lot of different exe files. Let's just keep scrolling. A lot seem to be from LOL drivers, the specific repository. And I'm thinking this LOL drivers is a repository which contains a bunch of living off the land drivers. Hmm. All right, this might be just a little bit topic, so let's just keep on scrolling. And if we go to the very end, we can see again Amplia security tool like Windows Credential Editor, WCE. This is actually a really legitimate post exploitation tool which is used by a lot of people. Some script kiddies love to use these kind of tools when they are compromising systems. Now, let us just actually go ahead and download this file to see if this is also being detected. Now, luckily for us, Kali Linux by default comes with this wce.exe inside its own, installation inside its own file system. So just need to do update db and locate. Now, yeah, it might be in an installable package. Well, that's okay. Even if we don't have wce.exe, I'm pretty sure it used to be here. We can try other pieces of malware which we do have inside. This is netcat.exe. Now, I'm not sure if this specific Yara rule set has anything for netcat. There's also wget who am I. I'm pretty sure Mimikatz. Yep. Mimikatz is there inside this rule set. So let's just locate Mimikatz. Right. We do have Mimikatz, so let's try that. Again, Mimikatz is a tool which is used, by pen testers as well as attackers when they are compromising a system, typically a Windows system, and they want to dump credentials which are stored inside that system. Or, it's used for a lot of different purposes to dump secrets from the system, to forge golden tickets, Active Directory pen testing, and so on and so forth. But yeah, In short, Mimikatz is a malicious piece of software, typically should not be seen on production systems. So let's just go ahead and see if mimikatz.exe is being detected. Now, since only the malware folder /tmp/yara/malware is being mentioned for monitoring, we will not be able to use any other folder to store all these malware. Of course, you'll have to go and edit your Wazoo agent configuration to sort of mm, what do you say, to sort of monitor for that specific folder. You'll have to modify your agent configuration if you want to monitor different folders. Since we are monitoring only this folder, we will copy our piece of malware onto that specific folder. Now we need to use sudo since that folder was created by root. And we just wait for Wazoo to sort of start picking up on this. Let's go back on to file integrity monitoring. Let's look at events there, and we can see that this file has been added, and that shows up as an event over here. Now let's head on back to threat hunting and see if an alert has been produced. And as we can see, as soon after the file added alert, we can see a file Mimikatz is a positive match for Mimikatz, as well as PowerCats, as well as Mimikatz gen strings. So now three different Yara rules matched for a specific file, which is, considerably amazing. Let's also see if this is able to identify a payload generated by the Metasploit framework. So what I'm going to do is to start up Metasploit framework, which is a tool which you use to sort of exploit into different systems. It contains pre-built exploits as well as the capacity to generate payloads in like a ton of different languages or file formats. So we are going to be using a typical Linux Metaprinter payload. And we are going to be generating this onto a file. So we are not actually going to be executing this payload on my system. We will only just generate this payload and try to see if that is being caught by Wazoo. So now how do we set the L host? The next thing to do is generate it as an ELF and onto Yara malware meta.elf. Now this is what we will need to do. Now again, this also gives me a permission denied. So let me just quickly head on there and change the ownership chrown. Now this will allow me to write files here. So let me just go ahead and write it down. And after we have generated the file, we can see that the file has been generated successfully, stored inside that specific folder. Let's head on back to file integrity monitoring, onto events to see if this has been detected here. Now we can see that the file being created has been detected successfully. Let's head on back to threat hunting and see if this has been matched with anything. Now, sadly, we can see that one alert is here as to the file itself being actually added. But apparently, the Yara integration itself has not really detected that file as a malicious file. Now, it might be a little bit late on executing and integrating, but now, in this case, this metaprinter file is not being detected as a malicious piece of software. Again, two things here. One is that the rule set, as was previously mentioned, is actually just a demo rule set. It's not really something which is fully fledged or fully featured. Now, you might need to search for other rule sets which give you much more of a comprehensive coverage. Yara rules. Typically, you can just go to Yara rules and you will be able to see a lot of different Yara rules over here. There is a GitHub repository full of these. And yes, you can use something like this to sort of detect what is going on over here. Now, since our integration itself, the shell script only uses one single file as part of, yeah, sorry, that should be under the Wazoo server. Now, we don't need to worry about the logs folder. We will only need to look at this. Yep. Um, on the Wazoo server, when we have defined the command over here, here we specify that the Yara rules to be used is a single file. It's present under /tmp /yara /rules /yara underscore rules dot yara. Now, this is the file which is going to be used when the Yara tool is actually looking for malware. And if any signatures are not there, then it will not be used. So also we can take a look at the shell script itself. Now cat the yara.sh to see that it basically just passes the Yara rules as a -r flag onto the Yara command. So now if I do Yara -h, I can see that the -r flag is to recursively search directories. Yeah, no. Um, here the rules file is being specified and -w. There are a bunch of flags here. Disable warning, -r for recursive, and it basically also adds only the specific Yara rules file over here, which means we will only be able to scan for signatures based on one single Yara rules file. Now, on a typical repo like this, which has like a lot of different Yara files, you can basically just use something like this malware index.yar and so on and so forth. Now, this one is an inclusion of a bunch of Yara rules. So, what we can do is clone this entire repository and use only a specific index file which we have over here. So, let me clone the entire repo. And now, when I go into rules, we can see a bunch of different index files over here. One, for example, here is malware index.yar. And we can use this, for example, to see if that expands our detection. And we're going to be copying this malware index.yar onto the previous folder as Yara underscore rules. And since this malware index.yar is just a bunch of includes onto the malware folder, we will also need to copy the entire malware folder over here. So this Yara rules.yar now contains a bunch of includes to the malware folder. And we also have the malware folder right here with all the different uh, Yara rules over here. So now, hopefully, this will be better at detecting the metapredator payload. So let me just go ahead and regenerate the metapredator payload onto a different file now. And this might be able to detect metapredator better. So let's head on onto FIN, look at events, and you can see that this event is showing up here. Scroll back to threat hunting, go to events, and again, file added to TMP era malware, but no alerts as to the actual file itself. Uh, Now, this also might not have been detected properly by Metapredator, and we can basically just look at this to see what kind of malware it is including. It's including a bunch of signatures from different APTs, and it's also including a bunch of PowerShell malware, SSH backdoors, blackworms, and different malware which we have. Nothing related to typical Metasploit framework, probably. Ransomware is also there, of course. And say, for example, it includes PW dump. So we are pretty much constrained by the number of Yara rules which are present inside the rule set which we are using. So now a typical approach would be to collect a lot of different Yara rules like these and start using them. And that typically helps us to increase our detection even more. And yeah, we are typically just pretty much constrained by the amount of Yara rules which are present in pre-available repositories. One thing which would help us well is to sort of consolidate all of these different Yara rules and try to use as many rules as possible to make sure that we are able to detect as many malware as possible. And yeah, as I was saying, let's try to look for PW dump. I'm pretty sure uh, Kali has something related to that. PW dump is there, but it's available as a Python file, and I'm not really sure if that's something which is detected. Let us still take a look at it. Yep, it detects quarks, PW dump, and not really something which is related to the Python script itself. Now, pwdump is a different Python script, but I'm pretty sure if you just put this whole user share directly under the file integrity monitoring watch of Wazoo, it should be able to come up with a lot of different malware which is present under my system. Now, since this is a Kali Linux installation, it by default has a lot of different malware. You know, for legitimate purposes for pen testers to use to sort of compromise different systems. But yeah, the idea is that it should be able to detect as many different pieces of malware as it can. Now, yeah, I think that should be it. We have a lot of different Yara rules which we can use. Of course, going forward, the steps from here would be to sort of configure the integration in a more permanent way where we basically just keep updating these rules as and when they get updated remotely. And we also utilize as many Yara rules as possible. And that would be it. Um, so, just to recap, we have seen how to use the Yara integration with Wazoo, which will involve a few steps. First step is to download and compile Yara on the system which is going to run the scans. Now, downloading and compiling Yara should be done at the endpoint level. which means this endpoint needs to use the endpoint that needs to detect the malware needs to be precompiled with Yara. And after downloading and compiling Yara, we download a bunch of rules for Yara to utilize. And the next thing is we configure a Yara integration for Wazoo by writing a shell script and adding file integrity monitoring by adding a specific folder to the files to be monitored in real time. And then we restart the Wazoo agent to apply all these changes which we have did. And then on the Wazoo server, we create a couple of rules and then we create a couple of decoders and we add one command and one active response item which uses the previously defined command. After we have done all these changes, we go ahead and restart the Wazoo manager. Um, and there it is. We should be pretty much all set up to utilize Yara to detect malware. And of course, any setup is as good as the amount of testing you can do on it. So we utilized first the malware downloaded, which is documented in the Wazoo documentation. We executed that shell script, and we had a satisfactory idea of what that does. And once we have been satisfied with what the Wazoo documentation provides, the next thing we did is we just go ahead and try to generate a bunch of our own malware and a couple of malware which we had like mimikatz got detected instantly. Now after that we generated a custom payload using Metapredator just to see if that got detected, and that did not get detected. So we tried one more enhancement by downloading a publicly available Yara rule set, and we tried to see if that would cause the Yara rules to pick up the Metapredator. We regenerated the Metapredator payload, but the Yara rules still did not locate Metapredator. Now, yeah, there might always be enhancements which we can do on top of this, which is basically just adding more rules and adding your own rules on top of it, your own Yara rules, which can sort of detect specific pieces of malware that you are interested in. And yeah, the next step would point towards that direction where you start adding to your rule sets and start detecting malware which present a real threat in your specific environment. Now, again, this is all based on a Linux environment, so I basically just compiled a few pieces of Linux malware and tried to install it on my system. Which again, some of them threw errors and some of them did not. Some of these malware was not detected, and yeah. So the idea here is that we try to include as many rules as possible which are publicly available to sort of benefit the whole detection process. And failing that, even when we have a lot of publicly available rules included, there might be cases where some specific piece of malware always slips past it. So, as an analyst, your job would be to go ahead and write your own rules which can detect threats which are plausible in your specific environment. And yeah, next steps from here would basically be to do something similar to this. Go ahead and customize your rules to sort of enhance your detection capabilities. That should be it. I will pause for a few moments so that we can look at questions from the team. The link for Wazoo, of course, the documentation link is right here. I pasted it onto the group chat. Hopefully, it went to the group chat. Yes. As there are many predefined and custom scripts, can we use such scripts? Of course, you can use the predefined scripts. Now, I just for the demonstration purpose, I actually tried to generate a lot of different malware in front of you. and tried to sort of demonstrate the capabilities you can see right here. There are a lot of predefined scripts like this. You can just integrate Yara straight away from Wazoo. But all that matters is your rule set, really. Once you have the basic integration going, the next thing you need to focus is on the rule set, be it Wazoo, be it Yara, whatever. Now, the Yara rule set, it might not be comprehensive enough to cover all different kinds of malware, but it should at least be able to cover some basic malware which is being generated on these systems. So always writing your own custom scripts, building on top of whatever is already there, always tends to be beneficial, because not only does it allow you to detect threats which are commonly known, it might also help you to detect threats which are more obscure, or threats which make sense in your environment but does not make sense in others environment, and so on. So yeah, to answer your question, you might need to write some Yara rules to sort of enhance your existing integration. Of course, you are more than welcome to just go ahead and not write anything at all, but rather just use the existing integrations. But as an analyst, to sort of maximize the coverage which you have, it always makes sense, and it is always preferable that you sort of add your own scripts on top of it to enhance coverage. Is Yara perfect for phishing detection? Of course, yes. The Yara rules repository, which I just checked out, actually had something similar to phishing, I think. There is an email index inside the Yara rules repository, and yep, I think there is a bunch of phishing detection Yara rules inside that. Because again, you can always go ahead and add more of your rule sets for detecting phishing. Now, again, any good engineer, uh, forget about the domain of SOC analysis, forget about the domain of cybersecurity, forget about IT. Any good engineer should be able to look at the capabilities of a specific tool which they are using, uh, and be able to adapt it to a wide variety of situations. Yara here, for example, is just a tool. It can be used to detect patterns inside specific files. Now, how you use it is up to you entirely. You can use it for phishing detection, you can use it for detecting malware, like a signature based antivirus, or you can use it to detect secrets. Of course, this can be also configured inside, let's say, a CI/CD pipelines where you would use to detect if secrets are being committed onto a repository. So yeah, there are a lot of different use cases for Yara. As a good engineer, you should be able to look at all different aspects of it and sort of try to build the integration to something which can really add value. And the attendance link, of course, yeah, I'll share it in a while. Don't worry about that. I'll just try to cover all the doubts which are here. I understand Yara rules. Is this a kind of app used in QRadar, as like QRadar manager manages it? Also, can we install other sort of apps in Wazoo? Yep. To answer your question, I'm pretty sure QRadar also has Yara rules integration, and we can also integrate with a lot of different apps with Wazoo. Uh, a typical SOC analyst will not just stop at downloading and installing tools onto their ecosystem. They don't just stop at the very first point. Say for example, a good analyst will not just download Wazoo onto their system and call it a day. There will be multiple tools, multiple integrations, multiple enhancements which you can do, and security is as much of an ongoing process as software development, or really building any sort of project. Security engineers are by second nature software developers, because you are still developing a continuously evolving application, except you only use it for security. So to answer the question, yes, Wazoo also has a lot of different capabilities to integrate with other applications. There are integrations where it can execute external shell scripts. Again, these shell scripts can do anything. They can call an external API to make sure that an MD5 hash is not malicious, or they can upload files onto a remote system to scan for viruses, or it can just be a simple shell script that looks at the file name to see if a file is not being created in the wrong folder. Or, yeah, all these are called integrations in Wazoo. In Wazoo, there is this concept called integrations, which Wazoo uses to interface with external tools or third-party applications. There are quite a few integrations for several well-known tools with Wazoo. Say for example, since Wazoo is a CM, you can integrate it with Source by using shell scripts. For example, there is this SOAR called Shuffler, which can be integrated straightforward with Wazoo. If you look at Wazoo documentation, you will see a pre-built integration for Shuffler. And similar to that, there are a lot of different pre-built integrations which Wazoo can use to sort of integrate with other different software which is there. And again, the capability of Wazoo not does not just end with monitoring endpoints. It can also be used to monitor cloud, where, for example, you have Amazon Web Services, AWS. You can have all your logs of your AWS account stored onto an S3 bucket, and you can have Wazoo pick up logs from there, sort of process them, and start uh, integrating those logs onto your environment. And you can also write rules to present alerts on AWS environment. You can do that same thing with Google Cloud or any other cloud provider. You can also integrate Wazoo with NIDSs like Suricata, or basically any other system. So yeah, there is always the capability to integrate with other different applications in Wazoo, which will sort of extend Wazoo's capability as well as the capability of your security operations in general. And again, if you don't mind, can you show us how to write the use cases? Well, this is a pretty generic question. I still don't get what this means. Um, well, similar to what we have created just now under active response, we have created a specific folder. Similar to that, we can write other integrations also. Say, for example, under this active response folder, you have by default a bunch of different. Oh, sorry about that. Yeah. So I was saying that the active response folder contains a bunch of shell scripts already. Say, for example, there is default firewall drop. Yeah, not really a shell script, maybe a ELF. But yeah, there are a bunch of different executables here which you can use to sort of integrate with existing services. There is a Kaspersky.py which you can use to, I presume, integrate with Kaspersky, and so on and so forth. So yeah, uh, basically, Wazoo integrations are just accepting alerts from a specific source, going through that alert, and adding on top of it. Uh, that's basically the whole idea of Wazoo integrations. You take an alert, you use that in a certain way, and you execute whatever custom logic you want on top of it. And finally, you will have some more actionables which are based on that alert. So yes, to write specific use cases, it is, to write specific use cases might not really be something which I can cover. Uh, but yeah, the general idea is that you can write shell scripts which can do what you want it to do. So one shell script here, for example, was to sort of use Yara to detect for malware. Similarly, you can write your own shell script, which can basically just add on top of it and and extend the functionality even further. I keep seeing screen is not visible. I hope my screen is visible for a few people. Offenses and events are visible on console, but risk scores are calculated for individual entities based on activities performed from source or attacker. Again, this is a little bit confusing for me. I can't really get what this question is getting at. The risk scores might be for the agents themselves, sorry, for the endpoints. Each endpoint might have a risk score based on whichever criteria that Wazoo decides is relevant for that. And yeah, so I think we have reached until the end of this little. I don't see more questions. So let's just stop here and we can proceed further. As I was saying, I think we have actually reached the end of the bunch of questions. Yeah, we have one final question over here. When we detect malware, how do we take action? Yeah, so this specific active response script which we saw, uh, it only executed the Yara tool and added a line to the log saying whether it was a malware or not. Typically, a full-fledged integration would check for matches, and if it finds a match, it will immediately delete it or upload it to a quarantine. And yeah, so that is basically uh, just modifying the existing shell script to include the specific action. So yeah, as I mentioned previously, you have integrations at the Wazoo level, which you can use to sort of extend the functionality of Wazoo. You will be modifying the integrations to sort of take the action for you. And yeah, what is the daily routine slash day-to-day responsibilities as SOC L1? L1 is the most basic level of SOC, right? So the daily routine is typically to look at uh, alerts which are coming in and to sort of follow a playbook. Say for example, as an L1, you might need to just look at certain alerts. For certain categories of alerts, you would typically have a playbook to execute. Say for example, if a malware has been generated on a system, you might need to get in touch with the owner of the system, ask them why they did it or how they did it or what exactly happened, get an all clear or write up an incident report as to why that specific alert happened. That would be the typical responsibility of an L1 guy. Now, if that specific case requires more attention, you might need to escalate it to L2 or L3 so that they can take care of the rest of it. And about logarithm, right now I cannot. We do not have much time, plus that was not the scope. We will be coming up with some more content though, which I will shortly be explaining to everyone. Next one is the SOC Analyst webinar. Is Web App Pen Test easy or SOC L1 for pressure? Totally depends on your skill set. How will we get the certificate for this event? You will get it through email as soon as you fill out the attendance form, which we will be sharing shortly. Can we integrate it with some messaging tool like Zimbra? Of course, yeah. You can write another shell script which basically sends the email for you. So yeah, you can integrate it with some other tool for you know Wazoo. All right, that should be it. We will actually have addressed some of the questions over here. Some of you are asking for explaining about other tools or sort of the day-to-day responsibilities of a SOC analyst and stuff. For all of you, we have a course coming up, which is basically just a SOC analyst course. Since this is a webinar, we will not be able to actually walk through much as well as not have a hands-on. But the course which we are going to launch for the SOC analyst is going to be taking you through all these responsibilities end to end. How to do your day-to-day job as a SOC analyst and how to improve yourself further, how to upskill yourself further. We will be explaining this with one of our other teammates. Varsha over here will be explaining us what we are going to cover as part of this SOC analyst course. And over to Varsha.
Hi everyone, hope I'm audible. Yeah, so I'm Varsha. I'm working as BD at Razz Security. I hope you all gained valuable knowledge and enjoyed our webinar. So we were just going through the feedback yesterday. From your valuable feedback, we noticed that many of you are interested in cybersecurity, but may not be having enough background knowledge, while others are eager to dive deeper into this field. So we have got something for everyone. That is from beginners to advanced learners. So we offer courses in multiple platforms, that is classroom sessions, live online training. And for those with busy schedules, our most affordable option is self-paced recorded videos. So to get all this, just visit our website, log in, and enroll in the course that interests you. So here's the demo. Mukesh is just showing you how to do it.
I hope my screen is visible for everyone.
Yeah,
All right, so you just basically need to head on to academy.razzsecurity.com. You might need to go to the login button over here, click on sign up, and sign up with your own username and password over here. You will receive a confirmation email, after which you will be able to finish signing up. After you have signed up, you can use your credentials to log in to the platform. And from there, you will have a page, or you will have a tab for self-paced courses where you can go and open this, and you will be able to look at self-paced courses which we have. And you will have another tab for live courses where you can apply for live courses either online or offline. You will just need to head on to live courses. Here you will have a specific uh, course here for the SOC analyst. You can go and start enrolling here. You just need to enter your details over here, and then you can download the brochure for the course. And please stop annotating. I have not really disabled that. So, all right. Yeah. So after you head on over to, as I was saying, after you have logged in, you can head on over to the live courses tab over here. You will see the course over here. You just need to enter your name, phone number, and address, and you can click on download brochure. You will be able to look at the course brochure. And you can also book a demo class if you need, and we will reach out to you. Or you can directly purchase a seat onto the SOC analyst course over here. We have a limited number of seats for each mode. For online as well as offline, different courses, different modes, we have a limited number of seats. So as soon as you click on pay now, you will be taken to the course description page, and you can immediately click on pay now and start paying for it. And after you have paid for it, you will receive a confirmation, and our team will reach out to you with further details as for the actual classes and the schedule of the classes. I think that should be it. Um, yeah, over to Varsha.
yeah. So for those aiming to become SOC analysts, we have got some exciting news. As Mukesh informed you that we are launching live online classes starting from next month in September, that is. Actually, the full course price is at 45,000, but for our most passionate learners, we are offering it as early bird access for limited seats at just 3,000 rupees. So don't miss out. Register now at Razz Security Academy and take your cybersecurity career to the next level. So make sure to subscribe our YouTube channel for more such informative things. Yeah, that's it. Thank you so much. Over to you, Mukesh.
All right. I think we are good to go. Thanks, guys. Thanks, everyone, for your time. We will be sharing the attendance link right here in just a second, and you will be able to fill out your attendances. And for those of you who are asking for the offline classes, it will be held in Bangalore, India. So for those of you who are here in Bangalore, you can come on to our office, which is right here, and we will be conducting the classes over here. For those of you who want the location, you can just search for Razz Security on Google Maps. You will be able to find us on Google Maps. All right, for the attendance link, I have pasted it onto the chat right now. So you guys can use that link to fill it out. And yeah, as we previously mentioned, the recorded videos for both of these will be uploaded for yesterday as well as today. You will have the recorded videos uploaded onto our YouTube channel. It says already filled, huh? And that should be it. For all of you, you can just fill out your attendance and then you will receive your certificates through email. For those of you who are interested in the full SOC analyst course, you guys can reach out to us either through the website, through email, or you can just pop up straight into our office. All right. Thanks, everyone. Thank you for your time.